Okay, guys, I think we can start today's session. So, as I mentioned yesterday, today we are going to discuss about ROS and embedded system. It's actually a big topic, but we are taking some important part of it. Okay, I know some of you are already working with embedded system, and some of you are expert in this field. But this chapter is about like how to interface and any embedded system, any kind of embedded system into ROS, and why we need to interface an embedded system to ROS. So I will explain those things, and then we will be starting with ROS Serial and ROS Arduino, and then I will be talking about Jetson Nano and Raspberry Pi, how to set up a ROS on these platforms. Okay, and next sessions maybe we can discuss these basic things like interfacing camera, then sensors, all this stuff into Raspberry Pi. Okay, so basically the intention of this chapter is to give an idea how to create a robot and how to program it. Like the ROS is actually the high level part of the robot. Okay, and there are some other low level stuff that we have to do, like interfacing sensors. We may need to control the motors, and also like while we choosing the computer for a mobile robot, we will be using like Raspberry Pi boards or Jetson boards, like in order to minimize the spacing and also the power consumption. So there are many factors. Okay, so let's see, like maybe we can take a typical robot, maybe mobile robot ROS. Let me just take an example. Okay, and then we can explain from that. Okay, or maybe we can take the diff board ROS. So this is one project that actually done by one of our course member in the first batch. Maybe I can share the link. So from this project, I think I can talk about the importance of ROS and embedded system. Okay, so this project is a very simple project. The objective is that moving the robot autonomously. It's a wheeled robot. There are two wheels, and there are multiple sensors mounted on the top, and there is a microcontroller, there is single board computer, all are mounted on the top of the robot. And the basic thing is that the objective is moving from A to B autonomously. Okay, so in order to create this kind of robot or any kind of robots, we may need to like I mean create the we have to design it, right? We have to design. So while we designing the robot, the some of the elements are like the circuit, how to create a circuit, how to design the electrical and electronics, and the mechanical, right? All these stuffs comes to designing. So in the electronics part, um, we need to like find the proper sensor. Okay, proper sensor and proper actuators, and the computing unit, right? The computing unit, how to process the sensor data and send the control signal to the actuator. That is what basically doing in the in any robot, right? So in this robot, what he does was what he did was like he chose a microcontroller platform for interfacing basic sensors and actuators. So like he interface the motor driver and the encoder and everything to a microcontroller platform. And in order to do the navigation like A to B autonomous navigation, he actually done using ROS, and for that he used a Raspberry Pi board, Raspberry Pi 4, and inside this Raspberry Pi he installed Ubuntu and he installed ROS 1, and he interface sensors like LiDAR okay, because that can't be interfaced into a microcontroller. So this is a circuit, okay. So from the circuit you can easily find like the Raspberry Pi is connected to the LiDAR, and the Raspberry Pi is also connected to a microcontroller board, which is a TNC board. I'm not sure you heard about the TNC board, which is a popular breakout board, and it's also very powerful. Like the latest TNC, it's not the latest. I think the microcontroller speed is about more than 600 megahertz. Let me check the speed. Yeah, I think it was 600 megahertz. Okay, so you can check how fast it is, like compared to Arduino or something. Arduino board, if you take Arduino board, that board is running on like 16 megahertz, 1.6. Okay, so just check the speed difference. If you check Arduino, yeah, just a sec. It's actually mentioned in the description, but you can check the Arduino board is having 80MeGA328, which is running on 16 megahertz. So he actually use the TNC board, and you can check the connection. The Raspberry Pi and the TNC board is connected through USB, right? USB, and LiDAR is connected to Raspberry Pi, and the TNC board, the TNC board is connected to the motor driver, and it is also interface to encoders. Okay, so this blue color, this blue color is for the motor module. Okay, the motor module is having the encoder. Okay, and this is a battery, and this is for interfacing. I think this is a motor driver, I guess. Okay, this is a motor driver, it seems. So the TNC microcontroller is interfacing to motor driver and encoder. Okay, and there is one thing missing here. He also interface IMU to the TNC microcontroller. Okay, so what we are talking about is how to communicate between these TNC microcontroller board and Raspberry Pi. So the Raspberry Pi is connected through the USB, right? So how is the communication normally? Like, what is the easiest way of communication between Raspberry Pi and a microcontroller board like Arduino? Which is the easiest communication? Can anyone say? Can anyone say what is the easiest way of communication between a Raspberry Pi? Yeah, I2C is there, but the UART communication. Yeah, UART. So UART or serial communication is the easiest way, because in most of the Arduino or boards like TNC, it is having a USB to serial converter, FTDI chipset, something like that. That kind of board can convert the USB communication to serial communication, which is the easiest, right? So obviously, like if you connect the Arduino board or TNC board to Raspberry Pi, it will be detecting as a serial port. Okay, TTY USB 0 or TTY ACM 0, or in Windows it is detecting like COM1, COM2. I'm not sure you have worked with this board, but literally it's like a plug and play thing. Like if you plug this board, it will be detecting us devices like /dev TTY USB 0 USB 1, something like that. Okay, so after getting the device, you can able to communicate through Pi serial or some kind of, I think we have discussed this in the intro class, like we can communicate using the serial protocol. Okay, but if you want to make a protocol, like UART obviously is a protocol, but if you want to make all the system as ROS like components, for example, just imagine this TNC board is acting like a ROS node. Okay, so this ROS node, the TNC board is a microcontroller, it's a hardware board, right? But internally, if it is acting as a ROS node, then what will be the result? Like from the Raspberry Pi, we can publish some topics to this board. We can subscribe the data from board to Raspberry Pi. So we are trying to create a hardware ROS node here. Okay, just imagine. So that will be better for handling or programming, right? So instead of working with the UART protocol, or instead of sending some characters to the microcontroller and reading the sensor value, in order to make the entire communication easy, we are creating another top level communication protocol. The UART is a base communication protocol, and using that protocol, we are creating a high level communication protocol. Okay, that is called the ROS serial. Okay, ROS serial. The intention is that using ROS serial protocol, we can send we can send or receive data from a ROS based computer. Okay, and that is not the main point, but you can make an embedded system as a ROS node. Okay, I hope you are aware of what is a ROS node is. A ROS node is a program simply, or a process which can able to publish data, subscribe data, and run service. Okay, and like handle parameters. Okay, so in this project, what he does was he actually converted this microcontroller into a ROS serial node. Okay, ROS serial node means a microcontroller board which is communicating to a computer using ROS serial protocol. Okay, and this ROS serial node, serial node can able to publish, subscribe. Okay, so the advantage is that in order to run the motor, you can simply publish the speed command to the ROS serial node. Okay, ROS serial node, which is the teensy board. Okay, so from the Raspberry Pi, you only need to publish to a topic the speed commands. So speed command will go to this node, and then it will set the motor speed. Okay, if you want to read the encoder text, just subscribe the encoder topics from the teensy board, and you will get the encoder text. So what is advantage? You don't need to encode and decode the data. The ROS serial protocol will do that. Okay, so actually interfacing an embedded system into ROS is like adding a hardware node. Okay, hardware node. So that node can able to publish and subscribe. I think if someone work with IoT using MQTT, I think the same thing is happening in IoT itself, like the publishing and subscribing. So the same thing is happening here. The ROS serial actually making the communication protocol from a computer to a microcontroller platform. Okay, so now we can jump into the ROS serial. Okay, ROS serial protocol. So just search about ROS serial, so you will get a lot of reference. So this is official wiki, and there are a lot of tutorials available. It's a very popular communication protocol in ROS 1. Okay, in ROS 2 it is micro ROS. Okay, micro ROS is one way of communicating with character device. Okay, we will be discussing that in the ROS 2 lectures. Okay, so ROS serial, and there is a lot of tutorial, and they're talking about the communication protocol, but we don't need to worry about the communication protocol. What we need to know is that how to program a embedded system, okay, using ROS API. Okay, then only we can create a ROS node inside a microcontroller. Okay, so how to program that microcontroller board in order to make a ROS node. Okay, so that is one thing that we have to understand. And the second thing is, when we connect a embedded system into a computer or Raspberry Pi is basically a computer, right? How to decode and encode the data that is sending and receiving from the microcontroller unit or the hardware node. So we need to run some programs in the computer side in order to decode and encode the data coming from the microcontroller and going to the microcontroller. Okay, so we need to like understand how to do the decoding and encoding of this ROS serial communication. Okay, so ROS serial is happening through the USB, okay, using the serial communication, and the decoding and encoding is happening in the PC side. Okay, the PC side is decoding and encoding it. Okay, so there should be some programs in the PC side to decode and encode, so we have to check that as well. Okay, so the common platform for ROS serial is of course the Arduino board. Okay, you know the Arduino is very popular. So I can also demonstrate the ROS serial using Arduino in this session. And yeah, so maybe I can directly jump into an Arduino ROS serial demo, so you will get a clarity, and then I will go through the other stuff. Like not only Arduino, we can interface different embedded system boards like TIVAC or mbed based boards, or I mean any board we can interface. Like we have that template to create the interface between any kind of microcontroller board. Okay, so the first interface is for the Arduino. Okay, okay, just a second. So I mentioned that there is two section for the ROS serial protocol. One is the client library, okay, so which is what we are running on the microcontroller, and there is a ROS side interface which is acting as a bridge, okay, in the PC side. So we have to program in the client side, which is the microcontroller, and we have to run a already existing code in the PC side, okay, for decoding and encoding. So this is ROS serial Arduino, and installing ROS serial Arduino is pretty easy. So yeah, Bharat, yeah, tell me. Yeah, PC means computer. Yeah, it can be Raspberry Pi, laptop, anything. Yeah, Teensy microcontroller board. Yeah. So so first maybe we can see the demo. Okay, then we can I mean switch back to the explanation of this. Okay, so what I have is a Arduino Uno board. Okay, Arduino Uno board. I think that is connected to the VirtualBox. Just a second. So in order to find the devices in Linux, USB devices. So as I mentioned, the Arduino board, Arduino Uno, is connected to this Linux computer. Okay, if it is Raspberry Pi, you can connect to USB. I am using PC, so I connected through USB, and so I am also using VMware. So there is some setup to share to the virtual OS. So I have done that, and if you execute the ls USB, you can find the Arduino Uno is got connected to the Linux system. Okay, it's got connected, and if you check the D message, okay, which is the command for checking the kernel logs, so you can find the USB device, that is the Arduino, got connected, and the serial port, okay, the serial port that it is got connected is TTY ACM0. Okay, so this is a device file for Arduino. I think you know about the device file is. The device file will be automatically created when we plug a device into Linux machine. Okay, but it will only create the device file if there is a device driver available in the kernel. Okay, so commonly the device driver for Arduino is available in the Linux kernel. So it will be automatically creating the device file. Okay, so TTY ACM0 is the device file. And Tejas is having a question. Can you shed some light on UDEV rules? Yeah. So when you communicate with Linux, when these devices communicate to Linux system, um, so there will be some permission required by the user to communicate with this device, because these devices are like low level system. So a user can't able to interact with these kind of devices. It require administrative privileges or pseudo privileges. So in order to assign permission for these kind of devices, there is a thing called UDEV rules in Linux. So just search about UDEV rules. I think it's not a big thing. It's simply like a file. Okay, just a file, and that file, if you put that file in some location, what happening is that whenever this specific device plug in to the system, the permission is already authenticated. I mean, you don't need to access through the administrator. The permission is already there. Okay, so the UDEV is mainly using for adding the permission for these USB devices. Okay, so when you write the UDEV file, you are basically adding this kind of line to the UDEV file. So basically it is having the ID, vendor ID, these value, like this information basically. So this is one of the basic information about the USB device. Okay, so if you add the permission to this device in the UDEV, whenever you plug that device in Linux, you will get that permission. Okay, so you don't need to use sudo to like access the device. Okay, yeah. So the question is, do we have to do this for ARPA? Yeah. So it is available in all Linux system. Okay, so you have to do that. It will be better to assign the permission in Raspberry as well, and also you can like change the device file name as well. So instead of TTY ACM0, you can actually redirect that into TTY Arduino. Okay, so so we can do that. I mean, this kind of remapping and also the permission. Okay, so there is another question from Rohan. So we don't have to sudo for the, yeah. So basically, like when you work with Arduino IDE and all, this kind of permission issue is very common. Okay, so setting the UDEV file will remove that that permission issue. Okay, I hope that is clear to you, Tejas and Rohan. Okay, so by the way, what we have identified was the USB is plugged in, and the device file is TTY ACM0. Okay, so now we got the device port. So now the next step is programming the microcontroller board. Okay, using client libraries. Okay, so the client libraries of Arduino can be used inside the Arduino IDE for making Arduino as a hardware node. Okay, so instead of explaining, if I can show you, then you will be getting that. So I have the Arduino IDE with me. Okay, the version is 1.8.14. So you can download Arduino IDE from the website for Linux, and I'm just starting the Arduino IDE. So in order to set the ROS serial client or serial client libraries in Arduino IDE is very simple. Just start the Arduino IDE and then go to the manage libraries option. Okay, manage libraries. So the manage library help you to install the third-party libraries for Arduino IDE. meaning like if there are many libraries available in Arduino, right? Like by default, maybe if you are not familiar, I can show you like these all are some kind of libraries, okay, for displaying, and for liquid crystal there is a library. So all these are like libraries, okay. So if you want to add some third-party libraries like ROS Serial library, what you have to do is just search here in the library manager, ROS Serial, okay, ROS Serial, and you can see it is already installed. The version of installation is 0.7.9. Okay, so you have to be careful. I think the 0.7.8 and 7.7 or 0.7.9 will work perfectly, okay, but 0.9.1 I don't know, like I got some error, but these version like 0.7, 0.9 is working perfectly, okay. So that is the library that you have to install, okay. You can simply press the install button and that library will be installing. So that's it. So that is a step that you have to do in the Arduino IDE in order to install the ROS Serial client library inside the Arduino IDE. Okay, so if you take any microcontroller board, there will be a Arduino. There will be a ROS Serial client like this. Okay, so using ROS Serial client, you can able to write your own ROS programs or ROS nodes. Okay, so after installing the ROS Serial library on Arduino IDE, just go to the examples and just go down and you can find the examples from the ROS Serial Arduino library. Okay, so there are multiple examples like Hello World, which is a symbol publisher. Okay, publisher, it is actually like publishing the Hello World. Okay, and there is a toggle PubSub toggle LED example. So I will be showing one by one. Okay, so this is the example that we are going to try, and then after that I can explain what is happening. So objective of this Arduino ROS node is that it will publish a topic called chatter, and the chatter is of type string, and it is publishing hello world data. Okay, so the type of message that is publishing is string, and the topic name is chatter, and the data that is publishing is hello world. Okay, so in order to upload the firmware, I think you may be familiar, first verify it, and then you have to be like careful here. Just select the appropriate board. So currently, like, we have selected Arduino Mega. It should be Arduino Uno, and then just compile it again. Okay, and also select the port. TTY ACM0 is the port. Board is Arduino Uno. Port is corrected. Yes, now we can burn the or upload the firmware. So let's see what is happening. Okay, seems like it is uploaded properly. Okay, so you can see it got uploaded. Okay, so we have completed the first code in Arduino using ROS Serial. Okay, so how to get the topic? I mean, currently we have flashed to Arduino, right? So how will we get this topic in the Linux PC? Okay, Linux PC, that is the next step. So what we are trying to do is we are trying to run a ROS node which is in the PC side. Okay, it can be Raspberry Pi or it can be laptop. Okay, so in my laptop side, I am running a node in order to interface the microcontroller board. Okay, so this example is already available. So you can see the Hello World example from the official tutorials, ROS tutorial. So that is what we are trying here. So this is a program, guys, the Hello World program. And after burning it, what you have to do is you have to do this step in the PC side. Okay. So that's actually very easy. Like, what you have to do is take a terminal. Okay, just split horizontally and maybe vertically. Okay, so in one terminal, the first command that we have to do is the ROS code, right? In a row, if you are working with the ROS1 system, the first command obviously is ROS code. So you have so you have started the ROS code. Now we can start the bridge program. Okay, the bridge program. So that bridge program now, that bridge program is communicating to the microcontroller. Okay, and after that we will get the topics. Okay, so that node is actually inside a package called ROS Serial Python, and the node name is serial node. Okay, that is already installed on your PC. Okay, that is already installed on your PC. So okay, and after that we have to mention the port name ACM0. I think that is enough. Let me check. Okay, yeah, it seems like it's working. Okay, so we have done this much of things. Like, what we have done was like started the ROS core and simply ran this node. Okay, so now you can check the ROS topic list. So you got the chatter topic. Okay, so we are not running any other node in the PC side. Okay, we are not running any talker or listener in the PC side. The only node that is running is in the Arduino side. Okay, Arduino is connected to the Linux machine. Okay, and this node, serial node.py is communicating to Arduino using the serial port. Okay, so when you start this node, you can see connecting to /dev/tty ACM0 with a default baud rate, that is 57600. And it is requesting for topics, and then the node actually find that it is having a publisher which is type string. Now you can simply echo that topic. So you can find we are getting the hello world data, which is actually from the firmware. Interesting, right? So you are creating a hardware ROS node. Okay, so I think it's very similar in IoT as well. Like from the Arduino board, we are keep on getting the data like topics. Okay, and also you can publish something to the board as well. Okay, so this is what happening with the ROS serial Arduino. I mean, if you are working with any embedded system and its ROS interface, this is what the basic intention is. Like, there is a communication called ROS serial, and using ROS serial, the embedded system can itself act as a ROS node. Okay, and it can publish and subscribe the data. So if you are interfacing a board to the ROS ecosystem or ROS board, then everything is using topics or services or actions. Okay, so now do you have that issue in communicating with an embedded system? No, right? We are not taking any pain. Like, otherwise you have to like develop a firmware maybe in C or like in assembly language, and we have to establish our own communication protocol, high-level communication protocol to decode everything. So yeah, so there is a question from Tejas. Can you show serial.py how the dev is taken as a parameter? Yeah, so the thing is that like here you can either device is taken as parameter. Yeah. So you can mention the serial port name as an argument, or you can, like, there is two methods. Like you can either mention port like this, or you can like directly give the serial port name as this. Okay, so this is how we can specifically mention the serial port name and the baud rate. Actually, when you work with the ROS serial library in Arduino or any embedded system, you are not mentioning the baud rate. Basically, the communication is serial, right? Serial communication. So you have to mention the baud rate, right? So by default, the baud rate is 57600. Okay, and the default serial port that the node is looking is TTY USB 0. Okay, so we can override both these parameters. Okay, we can override both this parameter, that is the serial port name and the baud rate. So in order to work with higher baud rate like 115200, you can actually set that in this program. Okay, you can actually override that baud rate inside the program, and then when you run this node, you can mention the device name and baud rate as a command line argument. Okay, so as a parameter, I think we can pass as a parameter. I think that is actually mentioned. Let me just check, because this can be passed as a command line argument. Okay, and I need to check the serial.py whether it is taking some parameters, ROS parameters for reading. Maybe we can check ROS serial Python. So Tejas, I think that is your question, right? So maybe we can check the node whether it is reading the parameter or the command line argument. So this is the code, guys, in the ROS serial Python. The code is inside the nodes. So this is a node that we are running. So this node, it's actually yeah. So basically, we can set the parameters inside the launch file, port and baud. So inside the launch file, if you are running this node, you can mention these parameters as private parameters. I think you know that, right? Like inside the node, you can mention the ROS param, port as TTY ACM0 and baud as 5760. Okay, so all these things are parameters, so you can mention everything in the launch file. So maybe we can check for some template. Just a second. ROS serial Python in launch file. Okay. Yes, similar to this. So this is how we can use the ROS serial node in a launch file. So we can mention the param like port and baud inside the launch file. Tejas, I think this is the answer of your question. Okay, so we can use the parameter like this. Okay, so coming back to the code, we have seen the hello world is publishing. Okay, and now we can switch to another program, then we can start explaining the code. Okay, so now another program that we are trying on the Arduino side is a pub/sub. Pub/sub, simply like let me check. The blink program may be the next example. Yeah, it is only having the subscriber. um, just yeah, pubs up will be good, I think. Yeah, so this program now, this program is having a publisher and subscriber, and this program is basically a subscriber. Okay, so we can maybe start with this. So this program, when you flash this program to Arduino, what happening is that it is subscribing to a topic called toggle LED. Okay, so whenever a data comes to the toggle LED, it will simply toggle the LED in the board. Okay, so on Arduino, there is an onboard LED available. Okay, so that LED will toggle. Okay, so what I'm trying to do is I can't able to show you the LED blinking because the cable length is very short. Okay, otherwise I can show you in the camera, but maybe we can try. Okay, so I just compiled it, uploading it. Okay, the uploading is done. So the next step is the ROS core is already running. I'm starting the serial node, and now when you run it, you can see there is a subscriber from Arduino, and the subscriber topic name is toggle LED. The message type is empty. Okay, empty is the message type, meaning nothing to publish. When you simply subscribe, when you simply publish to this topic called toggle LED, it will toggle the LED basically. Okay, so let me check the ROS topic list, so you can see the toggle LED. So what you have to do is, using ROS topic pub, you can publish the data to toggle LED, and once you do this, you can able to see okay, so I can see the LED is on now. Okay, the LED is on now, and if I am publishing it again, the LED got off. Okay, so it's basically like it is subscribing, the Arduino is subscribing, and it is controlling a pin. Okay, controlling a GPIO pin to switch on and switch off the LED. Okay, so this same concept can be applied to many things. Like if you want to like switch on something, okay, switch on some motors or something, you can use a subscriber. Okay, if you want to set the speed of a motor, you can use a subscriber. Like you can subscribe to an integer value, so that value can be set as the motor driver PWM or something. Okay, so there are many applications for the subscriber. Okay, so now we can try the publisher and subscriber. Okay, publisher and subscriber. So before flashing the code into Arduino, make sure you have closed the serial node, because the serial node is interacting with the hardware port, I mean the Arduino port. So if you flash the program to the same serial port, then there will be a clash. Okay, so just close this, and now you can flash this. Okay, so what is this program doing? This program basically acting as a publisher and subscriber. Okay, it is publishing, keep on publishing a string data in a topic called chatter, and we can also have a subscriber, so you can turn on and turn off the LED using this topic. Okay, yes, so let me flash it. Okay, let me flash it, just verifying, and building, uploading. Okay, so done uploading. Now I'm starting the serial node again. Okay, so now you can see it is detected a publisher called chatter and subscriber called toggle LED. Okay, so we can see what is happening for the publisher and subscriber. So just check with the rows topic list. You can see the chatter. So in one window, we can simply echo the chatter. So you can see the hello world is getting printed, and at the same time we can publish for the toggle LED. Okay, so rows topic pub toggle LED. Okay, so I can see the LED is on now. Okay, at the same time the publishing is also happening, and if I publish the toggle LED again, it will turn off the LED. Yeah, it's turned off. Okay, but the publishing is still going on. Okay, publishing of the hello world data. Okay, so this capability itself is actually like, what will I say, we can do a lot of things using it, right? For example, you can read a sensor from Arduino or any other embedded board, and you can keep on publishing the sensor data in a topic. Okay, so you will keep on getting the sensor data in the topic. Okay, and using that topic you can do any any decision, okay, in the computer side. And if you want to turn on some relay or control the speed of the motor, or move the servo motor, you can simply subscribe. I mean, this Arduino can simply subscribe to the speed value, and whenever we publish some data to that topic, okay, this code will subscribe and that set the speed. Okay, so this Arduino ROS serial library is having a lot of power, I will say, while you make a robot. A lot of things are getting simple because of this publishing and subscribing method. We can easily program it. Okay, you don't need to read the ROS serial data or something. You can simply work on the top level. Like, you only need to worry about the topics. You don't need to, like, if you work with serial programming in Arduino, you may be aware of maybe I can simply show you a serial program, software serial, or maybe software serial. So this is a typical serial programming in Arduino. Like, you have to open the serial port, then we have to print. Okay, so in the PC side we have to decode this information, but if you use ROS serial, you can simply work like a ROS node. Okay, so that is the flexibility that we are getting in the programming side. Okay, so let me know if you have any doubt in the concept side, not in the program, in the concept side, how the ROS serial library is working, what are the things that we can do. So in the concept side, if you have any question, let me know. Okay, so after that we can start explaining the code. Okay, so let me know if you have any question, guys. Any questions so far? It's okay, right? I think it's nothing complicated, I will say. It's very straightforward. Yes. So now we can start explaining the code. Okay, first we can start with the hello world code. Okay, so if you are familiar with the ROS CPP node, okay, maybe I can take the talker.cpp. which is actually from the official tutorial. Okay, official ROS tutorial. So this is the code for the talker.cpp. So talker.cpp, you know, it's simply keep on publishing the string data. Okay, the hello world data is keep on publishing. The same structure you can see in Arduino itself. Okay, so in Arduino you can see we have a publisher, and I think you are familiar with the Arduino loops, right? There is a setup function and there is a loop function. So the setup function is using for initialization because it will call once, but the loop function will run infinitely. Okay, so what happening is that these all are like global variables. Just a second. These all are global variables, and in order to work with the ROS serial library, you can use the ROS.h. Okay, ROS.h, and in order to have the string message in ROS from standard message, you can use the standard message / string.h. Okay, so this is the header file that you have to include, and other stuff, it's very similar. Like if you compare with the C++ program, ROS C++, you have to declare, you have to create a node object, right? You have to create a node object. So that is what we are creating here. We are creating a node handle, we are creating a string message, we are creating a publisher. Okay, publisher. So there is a slight difference in the syntax from the PC. So if you check the publisher in PC, I mean, there is a little difference. Okay, a little difference, but here it's like ROS publisher, chatter. Chatter is the publisher object, and also chatter is the topic name. Okay, and this is the type of message, ROS message, that we are using. Okay, and we are also like setting the data that we have to send. So this is the data hello world, okay, which is in a character array. So inside the setup function, what we are doing is we are initializing the node handle. Okay, nh.init node. We are initializing the node. Then we are starting the publisher. Okay, we are also like initializing the publisher. Okay, which is the chatter. So these two things are happening in the setup function because it is doing once only. Okay, only once. And in the loop function, the publishing is happening. Like we are assigning the hello data, like hello character array, to the message. Okay, string message. Okay, so in order to publish, I think you are aware, like we have to publish the string message, right? So this line is like giving the data to the string message. Okay, ROS string message. Okay, so hello is this. Okay, so hello containing a data called hello world, which is assigned to string message dot data. Okay, and this string message is getting published. Okay, so chatter here is the publisher object, and it is publishing, and we have to run the spin once. Okay, spin once, and if you want to add some delay, you can add it. Okay, so yeah, so there is a question from Tejas: how to deal with custom message in ROS serial? Yeah, so if you are working with ROS serial, if there is a custom message, what you can do is you can either create the ROS serial library using a script. Okay, and or you can add the header. Maybe I can explain that. So Bharat is having a question: what is spin once? So the spin once is also mentioned here, Bharat. So the same thing, like it is like after publishing, when we execute the spin once, then only it will be actually going to the queue, publishing queue. Okay, So it is actually similar to the C++ code that we have seen in the PC. So if you check spin ones, the explanation is here. So the spin ones actually there is another function called spin. Okay, so row spin and spin ones. So the spin ones is actually for like executing the callback as well as the queue. Like these publishing and subscribing is happening in a queue, actually set of queue. So the spin ones is actually executing the callbacks. Callbacks means like whenever a data subscribe, uh, there will be a callback execute. Okay, so all this publishing and subscribing will only work if there is a spin. Okay, it can be a spin once or a spin. A spin function will block the code. Okay, block the code, but the spin once will not block the code. Okay, so the explanation is here. So this is actually like they are saying for receiving any callbacks, but I tried without spin once for publishing. It will work. Okay, but if you have any additional callbacks, like if your program is having a publisher and subscriber, then they are saying it will not the subscriber will not work, something like that. Okay, so that is actually inside the Arduino as well. The same code, if you just compare with the ROS C++ Docker code, it is very similar. Okay, so we create a publisher, then we started the node, we started publishing. Okay, and yeah. So another point, another topic is like they just mentioned how to create custom message. So I work with custom message. So what we have to do is we have to what either make sure there are two ways actually. The ROS serial library, when you install the ROS serial library, you will get a folder like this. Just a second. I think not in this. Yeah, here. Oh, okay. I think in some different folder, I guess. Just a second. Sketchbook location is Arduino 1. So just go to Arduino 1 and you can see the ROS serial library which is installed. Okay, so this library is actually a collection of ROS serial client and ROS messages. Okay, so you can see the standard messages is here, then TF2 messages. Okay, all these messages are available. So if you want to create a custom message, the better thing is there is a string actually. I mean, it's not a string, it's a node. Just a second. Which is in the Arduino tutorial. So here they have mentioned a script. Okay, so here what happening is that, so if we have a custom message or something, the better way is that inside the ROS serial Arduino package, which is already installed in your system, there is a script called make library.py. Okay, so just run this node. Okay, maybe I can run it in my system. Maybe just run ROS serial Arduino make library dot. So what happening is that this command will be converting all the custom message and everything into Arduino serial client. Okay, so like if you check the home folder, you can see there is roslib, which is the created ROS serial client library. Okay, so you can create the ROS serial client library using script, also using the manage option in the Arduino IDE. Okay, so in this way you can incorporate custom messages. I think Tejas, I think this is the answer for your question. Okay, so this way you can work, but if you're working with some basic ROS messages, I think installing from the manage library option will be fine. Okay, yes. Okay, so I think we have seen the basic code, which is the publisher, and now we can see how the subscriber work. Okay, so subscriber, again the same pattern. If you check the talker, okay, talker and listener, right? Listener, okay. Listener ROS. Just a second. Yeah, so this is talker and this is the listener. So listener is basically a subscriber. Okay, so the same template is using in Arduino as well. Okay, so there is a question from Tejas. What if we put ROS serial package and custom message in same way and build and then include that in the code? ROS serial package and custom message in the same way and build then include that in the code. Let me check and build and then. So the thing is that actually there is an option, like if you want to put the custom message like custom message here in the installed ROS serial Arduino library, I think that will work as well. Okay, that will work, but you are asking okay, custom message in the workspace and build then. Okay, you are talking about like building the Arduino code in the system itself. Is that correct, Tejas? Okay, got it. Yeah, actually, see, what happening is that in the Arduino IDE, like when you press the verify button, it's using a different compiler. Okay, it's using a different compiler. Arduino using its own compiler, AVR GCC. Okay, so it will not like work with the Catkin make. Like if you put the Arduino node, this node in the workspace, it will not build like the regular workspace that we are using or regular node that we are working on. It is actually using a different compiler. Okay, but if you want to like compile the Arduino code other than Arduino IDE, there is Arduino CLI. Okay, that is one thing that we are using in some project. So using Arduino CLI, which is a command line tool for Arduino. So using this, you can compile the code, okay, without using the Arduino IDE. Okay, but we can't able to build the Arduino nodes in the workspace. That is what my understanding. Okay, so if you have clarification, you can mention, Tejas. Yes. So in the subscriber code, you can find the same setup, like we need to have a node handle, then we need a subscriber object, okay, topic of the a topic in which we are going to subscribe, and the callback. Okay, the callback, and this program, what it does is that whenever a data comes or empty data, anything, it will toggle an LED inside the callback. Okay, so the setup is the same. Like in the setup, we are initializing the node, then we are setting the 13th pin of Arduino to output, which is actually having the LED. Okay, then only we can set high or low. Then we are setting the subscriber. So in the loop, we are simply waiting. We are simply running spin once with a delay of 1. Okay, so the loop will be simply waiting for the topic. Okay, waiting for this topic. Okay. Okay, so that is a subscriber, and there is another question from Tejas. So if all are in the same workspace, we can still do the makelib.py. How will we know the path? Okay, so like when you do the makelib.py, if it actually searches, like imagine you have different workspaces, and in different workspaces you have different messages. Okay, so if all the workspaces are in is properly sourced, then the makelib.py will be detecting and converting that into Arduino equivalent messages. Okay, so yeah, so it will work. The makelib will work. Okay, in the same workspace or different workspace, it will work. Okay, stages. Okay, so this is a subscriber, and this is a combination of both, like the subscriber and publisher. So we have a publisher object, that is the chatter, and subscriber object, which is the toggle LED. And in the loop, it's keep on publishing the string data with a delay of 500 millisecond. Okay, so all this operation comes, it's doing in the single code. Okay, so the programming is not very difficult, because it's very similar to the ROS node that we have seen with the C++. Okay. Okay, so that is a code explanation. I think from the tutorial also you will get the detailed explanation. So if you check the tutorial, it is having the code explanation that I have done. Okay, they are also explaining line by line, but the tutorial is slightly outdated. Okay. Okay, I think for this topic, I think we can conclude for today. Okay, so I think from next session, I think I need to set up the Jetson Nano and Raspberry Pi, and I can show you some simple tips, to work with these boards and with ROS. Okay, so so now it's a time for questions. Like, so is that clear, guys? Like the ROS Arduino interfacing, like what are the benefits, what are the things that we can do with this, and the publisher, subscriber, all these things. Let me know if you have any question, guys. Let me know if you have any questions. Yeah, you can either comment or you can ask. You can ask or yeah. Okay, so Bharat is having question. Do we have only PubSub or any other method? So we have services, Bharat. I didn't see actions, but there is services, ROS service that we can do. Let me see if there is an example. Yeah, see, service client, service server. So that is also there. Okay, so like, yeah, maybe I can I can just run it. Just a second. Yeah, that's what I'm saying. Like the topics is like an kind of asynchronous way of communication. Like it's keep on sending the data, and whenever we need to subscribe, you can subscribe. Okay, but there is service, ROS service, which is like request response kind of thing. Okay, so when you initiate a request, then only it will give the data, something like that. Okay, so once we initiate the request, we have to wait for the response. So here like there is an example. um, no, this is different. Like so yeah, I mean, so this service, no, I mean like when we talk about ROS, I think you know the basic type of communication, right? ROS topic, ROS service, ROS action. So these are the basic three type of communication. So ROS topic is keep on sending the data, uh, um, but in service it's like it will not keep on sending the data. It's like for example, if you want to switch on and switch off something, okay, so for that you don't need to keep on sending the data, right? You just need to call it, and then after calling maybe it will switch off. Okay, something like that. So the row service is that kind of communication. Okay, but you can call the service from PC to Arduino or Arduino to PC. Okay, so both type of communication can happen, like the topic and service, a topic publisher and subscriber. So I think the Arduino or in the ROS serial, it's basically topics and services will support. Okay, so these are the two kinds of communication. Bharat, can you hear me, Bharat? Yeah, yeah. So let me check actually. So here okay, test request. Let me check for the service server. Okay. So in the meantime, if anyone having doubts, you can ask. Okay. So let me just burn this code. It seems like okay. So this is client actually. So the client, what we need is a server. So we can I mean, the client can be the Linux computer and server can be the Arduino. So in the server, whenever we call the service, it will be outputting hello world or something. Okay, let me just burn it. Or I will get an example from internet. Maybe like first test this example. Oh, sorry. Okay, so you can able to see setup service server on test serve, and yeah, so the service type is ROS serial Arduino test. Okay, so if you do the ROS service list, you can able to see the test service. Okay, so if you do ROS service call test server, I'm not sure, just okay, see, I just actually call the service and I just input some data, so I got an output from the Arduino. So this response that actually got from Arduino. Okay, so that is what this program about. Okay, like I think it is like checking some input, and if the input length is like divisible by 2, then it will return with hello, otherwise it return with world. That is what the program about. So you can check, yeah, see, if it is divisible by 2, if the it will return hello. Okay, so that is this program about. So the response, like we are sending a request to Arduino, and Arduino will return with the response. Okay, so this kind of communication is also helpful. Like if you want to switch on some LED, or if you want to like turn on a relay, something like that, then this kind of communication will be good. But the problem with the other kind of communication, you have seen the topic based turn off and turn on, right? So that is not a good way of communication for this kind of application. That is mainly for like publishing the sensor value, so that kind of context, that will be, I mean, best. But in order to turn on and turn off, I think this is the best way. Okay, the service call will be the best way. So in ROS Serial we can implement these two. Bharat, is it clear, Bharat? Okay, okay. Okay, so now I think we can conclude today's session, and in next session we will be like working on the SBC, and also I can show you the Tivasi launchpad if I have time. So like I have the Tivasi with me. The setup is similar to the Arduino Serial. So next class we can see this single board computer and ROS. It's very similar to like setting ROS on a PC. Okay, there is not much differences. Okay, so okay guys, I think we can meet on next session. Thanks for attending. So see you on next class. I will announce the date. Yeah, I announce the date soon. It may be on Thursday or Friday. I will try to make it on Thursday, but if there is any problem, then I will be doing it Friday. Okay? Okay, okay then everyone. Good night. Bye.